is expressed in the form of 2 to the power of n. So 1 over 16 can be changed into 1 over 2 to the power of 4, because 16 is 2 to the power of 4. And since they want the answer in 2 to the power of n, you bring 2 to the power of 4 in the numerator, and that will make the power negative. So 2 to the power of negative 4 is your answer. If they wanted the answer in positive indices, then you would just leave it as 1 over 2 to the power of 4. Then 2 to the power of then 2 times root 2. So when you're multiplying similar bases, the base being 2 over here, what we do is we add the powers. Now the root sign represents the power of 1 over 2. So it's going to be 2 to the power of 1 plus 1 over 2. Just 2 to the power of 3 over 2. That's your answer. Next question says, the histogram shows the speeds of cars traveling down a road. 24 cars travel faster than 40 miles per hour. How many cars travel less than 20 miles per hour? So 24 cars, I'm first going to come over here. So 24 cars travel faster than 40 miles per hour. Faster than 40 miles per hour is this part. So this has a class interval of 10. So if you try to find the frequency density for this, frequency density is going to be 24 divided by 10, which is frequency of class width, and that's 2.4. So this bar over here has the value of 2.4. So since in this block or bar, we have 3 complete squares, and at the third square, the value is 2.4, which means to find the value of one square, we divide 2.4 by 3, which gives us 0.8. Hence, the scale we're using is that for each big square, we're adding 0.8. So this is going to give us 3.2, 4, 4.8, 5.6. So now how many cars travel less than 20 miles per hour? Less than 20 miles per hour is this part. So that's 0.8. So frequency is frequency density times class width. So that's 0.8 times 20. And that gives us 16 cars. Then estimate how many cars travel between 25 miles per hour and 35 miles per hour. So 25 miles per hour and 35 miles per hour. These are the values that we're focusing on. So over here, the frequency density is 4. And the class interval from 25 to 30 is 5. So we're going to do 4 times 5, which is 20. And once again, the class interval is 5 over here, and the frequency density is 5.6. So now it's going to be 5.6 times 5, which is going to give us 28. So total cars for this range are going to be 20 plus 28, and that is 48. That's your answer. Then it says function f of x equals to 3x minus 5. Find f inverse of x. So to find the inverse of this function, let's begin with replacing f of x with y. So y equals to 3x minus 5. Now we're going to isolate x instead of y. So that means we're going to change the subject. So first you move 5 to the other side, and that's going to give us y plus 5 equals to 3x. Now we're going to get rid of 3 by dividing both sides by 3. So y plus 5 over 3 equals to x. Now last step is to replace x with f inverse x and y with x. So your inverse is x plus 5 over 3. If you compare the inverse to the original equation, you can easily notice that whatever function a term was performing in the original equation, it's doing the opposite in the inverse. As we can see, 5 was being subtracted in the original. In the inverse, it's being added. In the original, 3 was being multiplied to x. Now it's dividing. So that's how you can differentiate between the original function and the inverse function. Next question says the bearing of b from a is x. X is less than 180. Prove that the bearing of a from b is 180 plus x degrees. So let's make our compass for a and b. They told us that the bearing of b from a is less than 180, which means b will be in the second quadrant. So whatever this value is, like let's say this is x, this value is going to be 180 minus x. For this, you need to remember one important thing. In parallel lines, alternate angles are equal, which means if this is x, this is also going to be x. If this is 180 minus x, this is also going to be 180 minus x. Now they want us to prove that the bearing of a from b is 180 plus x. So to find the bearing of a from b, we start measuring the angle in clockwise direction from the north of b towards the line where a and b are connected, which is till here. So we already know this angle over here is x because alternate angles are equal. And this angle over here is 180 because it's a straight line. So 180 plus x degrees is your bearing of a from b.